I'm going to solve all your problems right now here in this room. Give me the first one. No, I'm not sure. I haven't met her, but I don't know. Can we solve her with that problem with sub-second live streaming? I don't know. Who knows? Anyway, thank you all for coming to listen to me talk about sub-second live streaming. For my experience, not that often you get to go to a conference as someone from a product management group. I've worked at Limelight for 8 years. I've been in operations. I used to sit in sat trucks at the side of events and doing coding and uplinking, and I've done operations. I've sat on the ops floor during one royal wedding, and I've sat as a product manager on the other one. And it's not often you get to come to this kind of event and actually have something that we've really attacked the requirements from the marketplace. We've really listened to what customers are asking us for. Not all live streaming use cases, but certainly use cases where latency is important. We've done a lot of research and work. We've come to a number of events with a product that we've launched. I can even have a camera next door which is streaming on my phone with no plugins natively. A really nice camera, bought a new Mevo, thought I'm going to come to the show with this out-of-the-box thing. Just turn it on, plug it in and go. So there's a few frame drops because we have great Wi-Fi connectivity and all that kind of stuff. But it's just really nice as a product owner, leading a product strategy to be able to come to an event with a product that really solves a problem that we've been hearing about for a while. And where we've really spent the time working with the customers who we feel it's important for. So it's great to be here. What I'm going to do, sort of 15 minutes or so, and take some questions from you guys. And please interrupt me if that's easier for you as we go. I'm going to talk a little bit about what we saw as the challenges and where are we getting these requirements from and what are we trying to solve for. A little bit on market trends. We obviously engage our customers directly, but we also go out to the market and do market research that tells us a little bit about what consumers are doing. So I'll talk a little bit about that. And I'll spend some time going through what we built, how it works, maybe some of why it works the way it does, and then sort of talk about then some of the features of the product both today and what the roadmap looks like. And one of the key things that we've seen, which is that one of the things that people are asking us for, not necessarily in traditional live broadcasting as it goes to OTT, but in made for web or made for OTT formats, is this level of interaction with the audience that otherwise you've got 3, 4, 5 apps going on. You've got to build a really big sprawling application environment for the users to interact with. So I'll talk a bit about that, and that's what we're going to try and cover. So what challenges are we really trying to solve? I leave this statement about 30 seconds up because it's interesting. If we look back to what HTTP live streaming was introduced to do, here's a recommended 10-second chunk. You're going to start up your player, you're going to get a buffer full of 3 of them so it can play back consistently, and you're going to get all the bits because it's a HTTP protocol, so it's reliable. You're going to get all the bits, and the buffer will be full, and it'll play. But it's going to take 30, 45 seconds maybe to fill up the buffer with those 3 10-second chunks, all the GOPs, and play it back, right? That's great for VOD, right? We want high quality VOD. For live streaming, there certainly are use cases where 30 seconds, when HLS came out, was certainly not comparable to what was happening with, at that time, RTMP still, right? So if you're in a gaming environment or an environment where there's a high degree of interaction, it's just not a comparable product. And what we've seen today is that on the HTTP side, it's still a reliable protocol, right? So it's still designed to get you all the GOPs and play them back, and you can reduce your chunk sizes. We've seen 2-second chunk sizes give you about a latency of about 6 seconds. We've seen 1-second chunk sizes. We deliver them across the network. We accelerate them. Gets you to maybe 3 to 4, but the performance on the devices really starts to break down with HLS. I'll talk about CMAF a bit as well because there are some other options. But there's certainly this requirement that we've seen through the marketplace of we would need to get to below a second. We want to do that with some consistency, and we need to be able to know that we can play that back natively. So this sort of idea of specialized plugins, or what I'm really pointing at here is the use of peer-to-peer, which is where you'd have sort of gone and think peer-to-peer technology might be the way that we can spread out the distribution and get some scale and get low latency. But you then have to build around an entirely different plugin environment. So one of the other things that we heard in the marketplace and people saying to us, look, we'd really like you as a content delivery network to help us at scale get below a second, but we do not want to have to deploy a range of plugins. We'd really like you to develop this around a natively supported format and one that's going to work across the majority of modern browsers and devices. So that was a key part of what we tried to achieve, and we really had to listen hard because we could say, well, why don't we build something that's based on a common protocol but isn't native to the devices? You just build an app environment. And you know, what we're hearing from broadcasters, content creators, live event distributors, people who do things like HQ Trivia, gaming and gambling, esports, is I'd like to use some standards, please. So make it natively supported. And then global scale, right? Everyone wants to be able to use a CDN to give us an input or push HTTP push or make us come to get their stuff from their origin or give us a feed from an encoder, and then we scale it. That's our job, right? That's what we do. So give me global scale with sub-second latency, make it standardized, no plugins, make it just work in all the browsers, and you know, can you do that for me, please? That's what the requirements in the marketplace have been. So no small challenge, but you know, it's interesting then to look at, well, where is that coming from? And part of what we do, as I said earlier, is some market research. So we, in addition to listening to what our customers want us to do, we do encourage ourselves to go and look out at what's happening in the consumer side of the world. And we do a report called the State of Online Video, which is about consumer habits and consumer behaviors. And it's done sort of independently of us. So, you know, we produce the report, but when we're doing the research, it's not obvious that it's us, right? So these are fairly straightforward research numbers. You know, primary research conducted, people do surveys and so on. So what this says to us, in the age groups that are consuming sports, which seems to be a lot of them, different types of sports, no doubt, different ways of interacting with them, but they're all saying, hey, actually, I would really like it if we're able to get a bit closer to the sport. So this, you know, helps us with things like, you know, my mate just texted me, ha ha ha, you know, like I was watching the Welsh rugby. Wales beat Australia in World Cup rugby for the first time in 30 years or something ridiculous like that at the weekend. Just texting my friend, you know, and chatting away. And it's like, if you're 30 seconds delayed, right, and it is an issue that people cite, and the end consumers do tell us that they would like there to be less of a delay from getting the broadcast. But then what does the broadcast delay mean? Typical broadcast latency, like screen to screen, right? You've got your cameras in the event, and you're doing production, and then you're going to send it across the bird. It's going to come down on a link, and it's going to get digital broadcast. You've got about 5 seconds from glass to glass, right? So if you're then taking that and then adding a 30-second latency by encoding and distributing through a CDN with standard 10-second chunks, or even if you're doing 2-second chunks, you're adding a whole load, you're getting up to 11, 12, 15 seconds outside of your traditional glass-to-glass cable TV latency. So the challenge is, if we can get below a second latency and then distribute either from the event, which in some cases, you know, when we talk about live sports, and we're saying it's not necessarily just traditional broadcast sports like rugby or soccer or American football, but it might be esports, right? Or it might be the HQ Trivia type live event distribution, or it might be gaming and gambling, right? So it's live event, not necessarily just sports, but it all comes together. If we can get within a second of glass to glass or a second of typical broadcast latency, that's what people are really looking for, and that's where these low latency use cases fit. So when you get under 500 milliseconds, people are starting to consider that you can't tell the difference frame to frame on different devices because you blink in 250 milliseconds. So it's difficult to spot any drift across devices. When you're over a second, you can still spot drift on devices. So if you're doing very small chunk streaming and you've got two devices side by side, they will drift slightly over time in and out with each other as they cater for retransmissions of packets to get the full GOPS. you'll get a slight drift on them. When you get to under 500 or around 500 milliseconds, you can't really see it. It's not necessarily frame accurate, and that's a feature we're going to work on and introduce, but as you get down under the second, these are the kind of things you start seeing. And then that becomes a really exciting proposition for live event streaming, where it's really important that there is some degree of synchronicity and things are generally in time with each other. If we look at what options we have for low latency live streaming, I talked a bit about a few of them. Let me just sort of reiterate again. From a content distribution perspective, you give us your chunks, you give us the manifest, and if you have decided I'm going to create 1 second chunks and a dynamic manifest, I can deliver that. We call that video acceleration. It does end up having an effect on the end device. There are cases where the buffer underruns pretty consistently on 1 second chunks, and the devices can have a really hard time keeping up with the rate of data exchange for that small amount of playback. But we can do small chunks from origins. The services we run in the CDN are all about taking in a feed, like I said earlier, take a feed, scale it for distribution, give it to everybody. So we run services that transform content. Single bit rate in, multi-bit rate in, we transrate, we transmux. So we can take the format in, and we can turn that into 2 second chunks. So you end up with about a 6 second delay. That's the lowest we've seen. We can produce all the formats you want for all the devices out. And essentially, because of the way that we run our CDN and the way that we build our efficiency into the CDN, you end up with about the same latency. But the interesting thing is, you still see drift across the devices. Okay, and this is all about the protocols that are in play and the fact that HTTP is reliable and it's going to adjust for the fact that, oh, I didn't get all the packets, I better get them again so I have the entire GOP, right? So there is drift, but you can get down. There are a number of ways you can get down towards that sort of second or so. So what's interesting is then what use cases are you catering for? There are many ways, including CMAF, chunk CMAF, right? It's an HTTP 1.1 based protocol. The client is interpreting the manifest. It's making range requests against an object that is on an origin somewhere. That's what CDNs do, right? We make range requests against objects and we distribute them. So HTTP 1.1 low latency CMAF is certainly possible through a CDN as well. We do work with a number of customers who are looking at CMAF as a way to get to about a second, and that's a good technology for that environment. It certainly works well with the CDN. The other thing that we then looked at was, well, we wanted to get under a second, sub-second latency of live video to anywhere in the world under a second. That's what we're being asked to do. That was the challenge we set ourselves. A globally scalable solution that is able to be played back, supported natively on standard browsers and in devices, right? So with global scale. And then the other piece of the puzzle was and is these sort of rich environments, right? So the ability to have this two-way interaction with the stream, the ability to send data with the stream that interacts with the environment that the user's in, that use the shared data objects that are available to incorporate interactivity into the viewing experience. A lot of the viewing experiences we see, someone's built a great player and it's got all the action going on in it, and then here's a timeline at the bottom and there's loads of overlays, and it's all really rich and exciting, but it's all separate data sources. What if you can combine that into the stream? You've got true two-way interaction across the stream in a shared object, shared by the server and all the viewers. Suddenly becomes a different proposition. So we spent a long time working on a product we call real-time streaming. This is based on the WebRTC format. So I've been talking a lot about HTTP being a reliable format. You're going to get the GOPs, you're going to get the whole GOP, and you're going to play it back, and you're going to fill up your buffer, you're going to play it back, and it's going to be consistent. And if it's not, you're going to get a rebuffer or a buffer underrun. You'll drift. With WebRTC, this is a UDP format. So what's more likely to happen is you'll see a frame freeze, right? Under a second frame freeze and it's gone. So we have to also build into the product things like forward error control. We have to build into the product things like automatic bitrate control from server to client rather than client to server. So we can detect and adjust for network conditions so that we can reduce those artifacts. So by focusing on a WebRTC solution, we're able to come to the market as a CDN should, with a way to ingest a feed from encoder, RTMP to start with, looking at SRT later. We then use the services and our service-oriented architecture of the CDN to distribute and manage that stream throughout our points of presence. And we transform that into WebRTC, and we manage connectivity and stream distribution in our POPs that are all around the world. We have over 80 different points of presence around the world. We have a 35 plus terabit per second egress capacity. It's not in every single one of those terabits per second right now, but where the demand is, that's where we go. It incorporates the standards that you'd expect of a CDN that's been working in the live industry for many, many, many years. Things like redundant RTMP ingest with seamless failover. If your primary feed goes down, you use the backup, right? We've learnt all of these lessons in live streaming for years and years and years. There's no need to forget all them in order to get to market quickly with a product that doesn't support all of those things. So there are another set of features that we have, right? So one of the things we realized and learnt about when we were doing proof of concepts with our customers on this product is sometimes there are problems in the networks in the last mile's congestion, and actually an HLS experience is going to be better. And a key thing for the consumer, which we also find out through all the survey work we do, the key thing for the consumer is they don't care what the format is, right? Of course they don't care, they want to watch the video. So we incorporate failback to HLS. We can then do things like get into corporate enterprises with the same infrastructure and service. You don't need 15 different services to get into different locations. Adaptive bitrate, I spoke about before. We're developing adaptive bitrate to work with our operating systems and our TCP stacks and our understanding of last mile connectivity issues. So we can, in the WebRTC format and WebRTC data structure, instruct the player of what to do. So we know that there are multiple bit rates available. We know this user is having some problems. We can signal to them to change the bit rate to enjoy that great technology of ABR that's available in all the HTTP protocols. I mentioned, following standard practices, geo-blocking, ACLs, tokenization, call support, TLS encryption, all the standard things you'd expect. So we've taken all of our knowledge and experience of those things and applied them to this product, so it comes out of the gate as, yes, your streams are authenticated. Yes, you can geo-block them. Yes, you can do all of the kind of authentication you do on a normal stream with these streams. So we've taken this format, which has not been scaled in this way in a CDN before, and we've made sure that all of those industry standard pieces come with it. There are analytics integrated with all of our services, this one as well. We're also looking at what's available from the viewer data. There's a specific set of data points available in the client from WebRTC clients. So we're looking at incorporating all of that so you get access to the same kind of viewer data that you can, obviously, because it's quite mature, get from an HTTP player. The WebRTC protocol is, it's not that it's brand new, really. It's quite thoroughbred. It comes from RTMP, it is based on RTSP, it's a UDP protocol. So what's interesting about it is in the death of Flash was about the plugins, right? The death of Flash was about the security risks that posed. And so what's interesting here is we have to be able, even though it's supported natively in Chrome on an iOS phone and I can just press play, people still want a nice environment, right? It's an application, it has to work well, it has to interact with all my authentication pieces, my subscription management, and so on. So there are of course, SDKs available, both for HTML and then we work for iOS and Android. So these help with the native integration so that you don't just rely on the browser and you've actually got a nice environment for the end user. And then all of the SDKs that we're developing and are going to have for this are going to support these shared data objects. So you get the two-way interaction with the data channel natively in the SDK and in the apps as well. So the two-way data object or the shared data object, this is about interactive applications. So think, I said it's not always just about live sports, right? HQ trivia type applications, or environments where there's betting, or environments where there's polling, or environments where there are tests, education, environments where there's multiple people working on something at the same time. So think use cases for live events that maybe are not media and entertainment orientated. We've had a great deal of interest in industrial video distribution for people to collaboratively work together. We've had security opportunities. We have media and entertainment opportunities and gaming, gambling, and so on. It's about being able to push data around in the stream as well. So I'm getting the it's time for beer call from the back of the room. So, you know, this is about low latency streaming. We know there are use cases. Is this going to work for everybody? It may not be right for everybody, but as a CDN and as someone who's engaged with the video workflows, we can deliver low latency streaming. CMAF, low latency streaming for HLS, chunk streaming, and now with WebRTC with real-time streaming. This enables us all to think about the workflow and the enablement of sub-second streaming and how that works with interactive environments. And as a CDN, we are bringing that to the market with global scale. So people here around might say, there's no globally scaled WebRTC solution. Yes, there is. Thank you very much. I'm around for questions at the Limelight booth, where we've also got our camera, which is still showing what people are talking about. I can keep my eye on everybody at the stand. Fantastic.
Steve is awesome. Round of applause for
Thank you very
Steve. Thank you, everybody. We don't have time for questions, but Steve will be at the Limelight booth and will be happy to talk to each of you and give you a cash prize for visiting him. I made that part up. All right, everybody. So before we get to the winner, a few housekeeping things. We do have happy hour from 5 to 6 right next door. Please drop by. It'll be a good time. And then we have a beer garden on the lawn. You can all come from 6 to 7:30. It's always such a good time. It's outside. It's lovely. The food is great. There's live music. So please, I want to see you all there. Before we do the winner, has anyone been in every Discovery Track session today? Is there anyone who's been in every one? You? Oh, you missed
Gentleman
one?
at the back, he's sat in that
You
chair
are?
all day.
You're the real hero. You are the real. I wish I had a prize for you. Right. Yes, a round of applause for that guy. All right. So, who is taking home the GoPro Hero 5? Please read the first name, and let's find who is our last winner of the day.
Okay, drum roll.
Drum roll.
It is Chuck Vaughan.
Chuck Vaughan.
Hey.
Yay, you win, Chuck. All right, that's Discovery Track. I'm Troy Dreyer. Been pleased to be here. See you tomorrow.